Welcome back. Today we are going to attempt the second question in this series, valid anagram. So given two strings S and T, we want to return true if T is an anagram of S and false otherwise. So basically an anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all original letters exactly once. So they give an example of anagram and anagram true because they're using the same letters. And then here we have rat and we have car. It's false because there's RAT here and there is RAC here. We are told that S is greater than 1, greater or equals to 1, smaller than this. Lowercase English letters, so there's no need for input checking. Unicode characters. Okay, let's deal with the follow-up later on. But okay, so taking a look at this question, I would say I'm definitely thinking along the lines of let's see. Again, you are given an array of letters, in this case like that, and what we want to do is to see if they have the same strings, the same letters in them. So if we arrange this to see the same letters in them, we want to I would think of perhaps adding these adding the letters into a hash map in the format of let's say you have something like this, so it'd be A1 and 1, and then you come in here, you add this additional A1, it becomes A2, and then it becomes G1. So when you, and so on and so forth, and when you are looking at the second array, as you can see, we are looking at this. What we want to do now is to use the existing array, existing hash map that we have to check these values. So when you come to n, you want to decrement this value. Okay, let's just finish the one in the first. So G is 1, R is 1, A becomes 3, and M becomes 1. So when you come back into this case, what you want to do is you want to use this existing hash map, and you want to decrement the value whenever you see a particular element. So N, you remove it, A, you remove it by 1, G, you remove it by 0, R, A again, you remove it by 1, R, you remove it to 0, A, you remove it by 1 again to 0, and then finally M to 0. And then lastly, what you want to do is you want to check if the hash map is empty, or rather check basically just check if all the keys, if all the keys in the hash map, all the values are 0. So if we base our solution on this, we can see that this will probably be an ON algorithm, because each addition to hash map is O1, and we are doing this on times over here. Do on times first, on times 2 times addition and checking and addition of on times 2 equals on. Okay, so based on this solution we should have an on answer. However, I'm thinking that there might be a faster, hence overall complexity is on. So this solution should be able to work. However, there might be a faster solution. Let me think about it. How about, what if we use sets? I think sets are going to be unique, so I don't think it will work, because in this case we would just be left with a set of perhaps we will be left with a set of A, N, G, R and M, and based on this set there is no way of us knowing whether or not the other is an anagram, because it might have the different number of a particular alphabet. So sets would not work in this case. Intersection of sets, how about intersection of sets? If we check 2 sets intersection, of sets, would that work? Well, I don't think so. Anyway, let's try it out. Can we do intersection of sets? Is on the best way? O1 intersection of sets. If we do this way, we would have this in. Nope. You can have a. Nope. Wouldn't work, because we might have differing letter counts if we use sets. So sets don't work, we have to do a hash map with numbers. Okay, I guess this is another easy question. The main challenge here would be, of course, again to familiarize myself with the Python syntax. So yeah, I guess on will be my best solution. Let's take a look at this, and yeah, let's just start implementation. Yes, I guess space complexity as well as space complexity equals on. Yep, because we are using a hash map, yeah, of size n. Yeah, so let's start. I guess we can use map equals to this, and then we have a string. So string, we want to enqueue the characters of a string into. How do we traverse into a string? Let's Google how to traverse a string in Python. For element in string name. Okay, I guess I should put my search in. For element in char in string s, if map char check if element exists in hash map Python. Let's try this. So we want to check if this s char is in the map. So we want to check if char is in map. We want to increment. So we want to have map char. Let's just use C, in this case C. Map C plus equals to map. We want to increment it by 1. Otherwise, we want to enqueue map C. Is map a reserved keyword? Is map a reserved keyword? Okay, I guess I'll use this, and this dictionary. So my dictionary C equals to 1. And once we have this, we want to have my C for SM3. We want to increment it if we find one letter that is there, otherwise we want to initialize this to 1. And once we are done with this, we want to look for C2 in S. I think we can use C again. For C in T, now the characters would have been already inserted into the map. So we want to see if if C is there. We want to minus it away, and then let's just move it down. Recording is like that. Let's remove this. Downwards, and we have this, my dictionary C. We want to minus 1 from the value, else my dictionary C is equals to 1. My dictionary key. In this case, if for every character in T, if the character of C in the second string is not found in the first dictionary, there can be a few scenarios whereby interesting. I almost forgot a situation whereby 2 strings might be a different length. So in this case, the requirement did not specify that t and s must be of the same length. All it said is that s must be bigger than 1, bigger than or equals to 1, and t is smaller than this. So no, I think they mean both of them are the same, but they didn't say that they must be the same. So I think the first thing we must do is to check both length of s and check length of string Python. If length of s is not equals to length of t, return false. We must have this check. Right, I believe this is correct syntax for Python. So after this solution, after this line, both of them must be the same length. And then when you come into this situation, there are two scenarios whereby all are in, and then when you find a particular character from this dictionary here, you can return false as well, because what happens here is that there is a char in t that is not found in s. Here it is found in s, and then what we want to do is to minus away the count to make sure that all, and then lastly we need to have a check. We need to have a check here to make sure that both dictionaries have, to make sure all keys in the dictionary have a value of 0. So let's just see. Have a chat GPT window open nearby in another window to make sure that I can Google some syntax facts. Let's see, my is this all 0 all. Okay, I've seen this particular line online, all 0 equals all, value equals 0, 0 for value in my dot values. Okay, and then if all value equals 0, 0 4, we want to check if all values in dictionary are 0. So apparently there's this very concise line that loops across for value in my dot values, value equals 0, and then you use all. I definitely have to Google and read more about this, but for now let's just assume that this is correct and check all value equals 0 for, and then if this is true, return true. Else return false. This should work. Let's try this in to trace this algorithm here with Anagram. and then we have this here. Yep, so if we pass in the first one, it will come out with the map that the calculation that I had previously. So let me just restore my okay, let me just do something and restore my clipboard. Yep, here go, and then let me just copy this and then restore whatever I'm doing. And let me paste this below. Okay, so the first thing we want to do is we edit here, add 1 to the solution, else we initialize it as 1, and then when you come in here you want to have 0, -1. Yep. It's quite self-explanatory. We will come in here the first round for your first in S. What we will do is we will populate this first loop. For first C, we will come into my dictionary. My dictionary would be, if C is in my dictionary, which is not, we will initialize it as 1, A. After that, N would come in, N would be 1, G would come in, G would be, sorry, A would come in again, and it will be A will be 2, and then G will be 1, R will be 1, A will be 3, N will be 1. Then we move on to T, and we decrement the values. Once we are done with decrementing the values, we check that all values in the dictionary are 0. Yep. And if at any point in time we check that there's a character on T that is not found in S, we will return false. So let's try it with a situation where there is RAT. So let's try it with RAT. So RAT would actually come in this particular hash map here. What we are looking at would be for us to have R1, A1, T1. And when we come here, we would check if C is in my dictionary. So C, immediately character C is not found in S. So C is not found in my dictionary. We'll remove it right away. Okay. Yep. Sounds good. Let's try and take a look at our solution with some test cases. Let's run it with the first test case. Oops. Let's check this and let's run it again. Case 2 is correct, and let's submit it. Okay, so we have a wrong answer at the last second. It's a huge test case here. I must have made a mistake because the expected output is supposed to be false. Sorry, the expected output is true and my output is false. Why did this happen? I don't think this is the issue, but let's just put it here. Length of S is not length of T, and then the length of S is during the question dictionary. Hold on. if I fix this situation, let's see if this works here, and let's remove this. Let's just run this again. Oh, this works. So the problem was with is not. Interesting. Okay, so I assume that if I add this to my solution, this should work. Let's try with this to submit this. And okay, here we have it. I guess it was a pretty long video, but yep, glad we got it through.